Hello, in this lecture we are going to study about our next concept, functions, as part of the course Mathematical Foundations of Computer Science. So we will see what is a function and what are the different types of functions we have, and we will see the different operations what we can perform on functions. Why do we have to study this function? We know that when you write programs, you write functions in that program, right? For example, if you take Python programming, in Python programming, you will be defining some functions, and those are user defined functions. So those functions are nothing but a piece of code, a small block of code which takes an input and gives you an output. That's why we call it as a function. And generally any common problem, or any computer science common problem can be converted to a function, and we can try to solve that function. One good example to understand this function where it is really used, if you are studying machine learning in regression analysis, if once you have a line equation y equal to mx plus c in regression analysis, you try to optimize it. You try to optimize the function using gradient descent, optimization using gradient descent. So there you are converting this as a function, and you are trying to do some derivatives, partial derivative or second order derivative, and you try to find out the optimized values of m and c. So there we convert this problem as a function, and that function we try to optimize it. I think optimization means either maximizing or minimizing. So not with much introduction about functions, let's see what is this. So it's very important in mathematics and computer science because we are able to convert everything into a function. Functions are used to represent how long it takes a computer to solve problems of a given size. Okay, so you might have heard about time complexity and space complexity. So we try to represent the time complexity as a function, space complexity as a function. So many computer programs and subroutines are designed to calculate the values of functions. So one best example to understand function can be, suppose each student in this MFCS class is assigned a grade A, B, C, D, F. So this can be a function, or we can say function is nothing but a mapping between the inputs and the output. In Python programming, you write def, def, you define a function, def function name, you pass some arguments, it gives you some output. It means it is taking some input and giving you the output. Same way here, this is the name is the input and grade is the output. That means you can assign. So definition, you see, a function f from a to b is a assignment of exactly one element of b to each element of a. Okay, if a and b are not empty sets, so we have two sets a, we have set a and another set b. So that we are having a mapping between one input to the output. So this is a function. We write like this: f of a equal to b. It means b is the unique element of set b assigned by the function f to the element a of capital A. See the definition, how beautiful it is. F of a equal to b if, we can write it like this: if b is the unique element of b, capital B, set b, assigned by the function f to the element small a of the set capital A. Okay, so we write it like this mathematically: f colon a to b, like this. Sometimes function also called as mappings or transformations. So we have a concept of domain and codomain. What is this? If f is a function from a to b, we say that a is the domain of f and b is the codomain of f. F, that input side, input part is the domain and the output part set is the codomain. So also if you write f of a equal to b, we say that b is the image and a is the pre-image of b. B is the actual image and a is the pre-image of b. Then the range or image of f is a set of all images of elements of a, right? So what are the domain, codomain, range of the function? Domain means that input part is called domain, this output part is called codomain. Range is nothing but, here the range will change. You see the definition here. Range or image of F is the set of all images of elements of A, right? So you see, for each element in A, this set A, what are the images? For Adams, it is A. For Stowe, it is B. For Woodfriend, it is C. For Rodriguez, it is A. For Stevens, it is F. So only these four elements, A, B, C, F, forms the range. Not all the elements, only the ones which are mapped forms the range. So if there are two functions f1 and f2, right, then f1 plus f2 can be written as f1 of x plus f2 of x, just addition of two functions. F1 f2 multiplication can be written as f1 f2 of x is nothing but f1 of x into f2 of x. Take this example here, f1 of x is x square, f2 of x is x minus x square. What is f1 plus f2? It is simple addition, x square plus x minus x square. So answer is x. And what is f1, f2? It is nothing but x square into x minus x square. So x cube minus x power 4, simple. Now we have three different kinds of functions. First one is one-to-one or injective function. Okay, so what is this one-to-one function? A function f is said to be one-to-one or injection if and only if f of a equal to f of b. Implies that a equal to b for all a b in the domain of f. Let's see some example here. See, so we have a set A, that is small a b c d, b 1 2 3 4 5. You see, f of a is 4, f of b is 5, f of c is 1, f of d is 3, is 1 to 1. You see, there is exactly 1 to 1 mapping. It means in programming perspective, if I say, if I have one input, I definitely have only one output and different, distinct. Okay, for one input, I have one output only, and input should be different, outputs also should be different. There should be distinct elements. Then we say it is a one-to-one function. Next, on to function or surjective. Here it says that when you have a program, right, these are the inputs, these are the outputs. In programming perspective, if you see, one-to-one says that for every input there should be only one output in the set B. But onto says that for every output, there should be some input. For every output element here, definitely there should be some input element. Okay, that is what onto is about. So if and only if every element B, there is an element A. For every output, there should exist at least one input. Okay, so this case, you see, for every output here, there is at least one input. One for this output 1, for this 1 we have C as the input. For this 2 we have B as the input. For this 3 we have A and D as the input. Okay, this is onto or surjective function, right? Is this one-to-one? No, it is not one-to-one, because out for input A and for input D, there is only one output 3. Therefore, it is not one-to-one. And the last one, one-to-one correspondence or bijective. So the definition is simple. Anything which is both one-to-one and onto is called a bijective function. It should be both one-to-one and onto. So let us see some examples and try to identify the function types. See the first one. If you see, for input A, there is 3. For input B, there is 1. For input C, there is 1. For input B, it is 4. Right? So for every input, there is exactly one output. Therefore, this is 1 to 1. This is 1 to 1. Second one, you see, from A, I am having 2. From B, I am having 1. For C, I am having 3. From D, I am 2. You see, for A and D, there is 2 outputs. So this is not 1 to 1. Not 1 to 1. It is not 1 to 1 because A and D are yielding same output too. 1 to 1 means one input, one output exactly. Then what is this? Let us see whether it is onto or not. Yes. See, for every output, there is definitely one input. Therefore, it is onto. Third one, see, A is mapped to 4, B is mapped to 1, C is mapped to 3, D is mapped to 2. This is 1 to 1 because there is 1 to 1 mapping. Is it onto? Yes, onto also. Why it is onto? Because you see, for every output there is definitely some input, therefore it is onto. Therefore this third function is a bijective function. Next, the other two examples, if you see, A is 2, B is 1, C is also 2, D is 3. This is not 1 to 1 because A and C are yielding 2 as output. And this is not onto also because this 4 is an output, it is not having any corresponding input here. Therefore, this is not 1 to 1 or not onto. This case, if you see, A is input 1 is yielding 2 outputs. Therefore, it is not 1 to 1. This is not 1 to 1. Okay, what about onto? Yes, it is onto because for every output there is some input. So this is onto, right? So next concept, composition of functions. So when you have two functions f and g, you can write f of g of x, okay, which is nothing but f of g of x. Like this we have to write, that is composition of functions. And f of g of x is not equal to g of f of x. Both are different. Commutative property does not applies to this composition of functions. So g be a function from set A to set B, and let f be a function from set B to set C. Okay, g is a function from A to B, f is a function from B to C. Next, the composition f of g is nothing but a function from A to C. Okay, so how to write f of g of x is nothing but f of g of x. So let's try to solve this. F of x is 2x plus 3, g of x is 3x plus 2. Let's find out what is f of g of x. So this is nothing but f of g of x. So it is nothing but f of g of x is 3x plus 2. This is nothing but f of 2x plus 3 means in place of x into put this value. So it is 2 into 3x plus 2 plus 3. So this becomes 6x plus 4 plus 3. So this value is 6x plus 7. This is f of g of x. Now let's try to solve g of f of x. G of f of x. It is nothing but g of f of x. So what is this? G of 2x plus 3. Now instead of x at g, put this 2x plus 3. So 3 into 2x plus 3 plus 2. So this is 6x plus 11. Okay, both are different. Inverse of a function. So suppose a function, what is inverse of a function? A function f of x is x plus 1, its inverse will be, now you have to find out this x value. You have to find out this x value. So it is y equal to x plus 1 is the function, x value will be y minus 1, right? That's what inverse is about. So let f be a one-to-one correspondence or bijective from set A to set B. The inverse function of f is the function that assigns an element b belonging to B to the unique element A in A such that f of A equal to B. See here, inverse is denoted by f inverse. So when you write function f of A equal to B, f inverse of B will be A. F inverse of B will be A. This is the inverse. So if you are given a function, right, what is it should be one to one. It should be one to one function. Let's see the example here. F be a function a b c 1 2 3 such that f of a is 2, b is 3, c is 1. So f the set is like this. I have a b c and 1 2 3. So a is to 2, b is to 3, c is to 1. This is a function f mapping from a to b. So inverse will be here. You have to write f inverse of 2 equal to a, f inverse of 1 equal to c, f inverse of 3 equal to b. Reverse. For 1 it is C, for 2 it is A, for 3 it is B. This way you have to write it. Okay, yeah. Some problems on what we have seen. So your given functions are like this. Find out whether they are one to one, on to, or both. Okay, which can be easily solved by drawing some diagram. Now determine whether each of these functions is a bijection function. Are they bijective functions or not? So you are given some function, you have to verify whether they are one to one, on to, or not. Maybe you can take the first one. If I take f of x equal to minus 3x plus 4. So let's take some set of values as x values as 1, 2, 3, 4. If I take this real number, so I will include 0 also here, 0, 1, 2, 3, 4. And here if I put 0, you put x as 0, this becomes 4. For 0, it is 4. For 1, it is, when I put x value as 1, this becomes 4 minus 3, 1. So for 1, it is 1. I'll write it neatly here. F of x equal to minus 3x plus 4. Assume some x values as 0, 1, 2, 3, so on. So for the input set, I have 0, 1, 2, 3, 4. In the output set, if you substitute 0, this becomes 4. For 0, the output is 4. When you put 1, 3 into 1 minus 3 into 1 minus 3 plus 4, it is 1. So 1 to 1. Then put 2, this becomes 2. Put 3, minus 3 into 3, 9, minus 9 plus 4, it is minus 5. Put 4, minus 3 into 4, 12, plus this is 8. Like this is going. So you have to verify for at least 15, 10, 15 values and tell whether it is 1 to 1 or on to or both or not. Okay, that way you can solve. So this is about functions. We have studied about different types of what is a function, different types of function, function composition, and inverse function, right? So in the next class we will study about relations. Thank you.